Your prompts are source code. You are a programmer. I believe that software of the future is going to be extremely soft. You're going to say, I have a company of 150 people. They're in Chicago, they're in Columbus, they're in New York, and they're in San Diego, California. Go out and find all of the tax code that's required to run payroll and pay them all at the end of the month. And that will be software. I just gave it source code, and it's going to do the rest. It's a robot that has an agency built in. We're starting to see it being able to go do things for us. All right, let's get just a little, this is like as technical as we're going to get, okay? Tokens are how it thinks. It doesn't think in words. It certainly doesn't think in paragraphs or concepts. It's in these tokens, which are little bits of concepts in vector space. Well, that's useful, Jim. What the hell is vector space? Okay, vectors. Trying to bring out the cats again. Here is a vector for cats. They are animals. They have fur, tail, claws. Well, they're also house pets. That's kind of a different vector. They are also part of our language. You're a cool cat. You're a crazy cat. You're a hip cat. They also are a meme on the internet, and yes, they are trying to kill you. These are all vectors of the same word, right? So that brings us to support vector machines. Here's your database, and your job is to write an algorithm that separates the green from the blue. Cool, done. The only problem here is that there's a couple of vectors there, a couple of support vectors that are right on the line, and so confidence is low for those. So I'm going to rewrite the algorithm to give me wider margins, like confidence goes up. Yay, I did it. And then I look at my actual real live data and, oh, it's a mess. So I write this really complex algorithm that separates them all. And it does it beautifully, except confidence is pretty low because it's all over the map. And if you put a new dot in there, having it figure out whether it belongs to green or blue, it's just all over the map. That's if you look at it in two-dimensional space. We're going to look at it in three-dimensional space, and we're going to turn it a little bit, and then turn it a little bit more, until finally we can see a clear path to writing an easy algorithm that actually separates the blue from the green. Because the computer can see in 3D when you talk about vector space. In fact, the computer's not limited to 3D. It can look at this data in thousands of dimensions, which is where the visual analogy totally breaks down. Because if you look for hyperdimensional vector support machine imagery, you end up with stuff that doesn't make any sense anyway. That's what it can do. It can categorize and separate and figure out how these words come together.